Graphing v-graphs. Let's start with this form of an equation. It looks a lot like point-slope form, except for the absolute value symbols. From this form, we can see where the vertex would be because it's the opposite of that negative h and the opposite of that negative k. But we're more familiar with the form where we get y by itself because for graphing purposes, that's what we usually do. So if we start with y minus k outside of the parentheses, we can just add that k to both sides, right? And as we do that, notice that we're changing the sign of the k. So what we're left with is an equation where we do need to take the opposite of h, but we no longer need to take the opposite of k. And that's why when we see examples written out with numbers filled in, we only take the opposite of this term, but not this term. Remember that the a out in front serves two purposes. The a tells us whether the v is going to open upward, like the letter v, or downward. That comes from the sign of a. So if a is greater than 0, it's going to open up. If a is less than 0, it's going to open downward. The value of a, the absolute value of a, is the ratio that's like the slope. In either direction, the ratio is the same, but it's going to seem to be a positive slope in one direction and a negative slope in the other direction. Let's look at some examples. Here's an example written in the point slope form. So we can see right away that the vertex is at -1, +3. But let's go ahead and add that 3 to the other side so we get y by itself. Okay, this is the form we're used to looking at, right? So we already know we've got a point at -1, 3, and that's our vertex. Now because of the sign of a, this is going to open downward. Let's plug in some x coordinates, okay? In our table of values, I'm going to choose x values that are to the left and to the right of the vertex because these graphs are symmetric and the vertex is the center from left to right. So since I've got a point at -1, I think I'll plug in -2 and 0 to begin. So if x was -2, I would get -1, but then take the absolute value of it, so it'd be +1 times -2 is -2, and then -2 plus 3 would be equal to just 1. If I plug in 0, I get a 1 in my absolute values, so 1 times -2 is -2 plus 3 is also 1. Interesting. Let's see what that looks like. So at -2, I'm up at 1, and at 0, I'm up at 1. Notice that this is a symmetric graph, and so when I picked x values the same distance from the vertex, their y coordinates were the same. That should always happen with absolute value graphs that are oriented up or down, like these. We could plug in more points, but what we're going to find is this ratio right here, 2 down, 1 over, is going to repeat itself. Because basically these are linear equations, but that absolute value creates that bounce that makes it a v. So in the other direction, we've got down 2 over 1, down 2 over 1 repeats. And so our v is going to go down through these and down through the others, like that. All right, let's look at another example. In this one, we have very few numbers, but that's just because some of the numbers are 1s and 0s. They don't stand out. A is 1 when it doesn't appear because it's a coefficient, and that's our multiplicative identity right there. And similarly, k must be 0 if it doesn't show up because it's added, and 0 is the additive identity. You can add it to anything and it doesn't change the value. So our vertex for this one must be at 4, 0, which is right here. So if that's the vertex, and if a is a positive number, then the v is going to go upward from there at a ratio of 1 over 1. So we can plug in values, or we can use that ratio to find some points. It should go like this, and it should go in the negative direction, like that. Well, let's plug in a couple and see if we're right, just to verify that. How about if we try plugging in 2 and also 6? All right, we should get 2 for both of these. Let's try it. So we've got 2 minus 4 is -2, but take the absolute value, so 2 times 1 is 2. There you go. And let's try 6. 6 minus 4 is 2. Absolute value of that is 2, and that leaves 2. So it verifies what we were already seeing in the graph. So there's two ways to find more points. You can either use A, or you can plug in points, or you can do both to check your work. Let's consider the symmetry characteristic of V-graphs. I'm going to plot these 2 points, and this is the only given information about this graph. So we've got a point at -3, -1, and also at +5, -1. Now, based on what we just observed in the previous 2 graphs, since these 2 points both have the same y coordinate, we do know a little bit more information. Halfway between these points will be the center of the graph. So halfway between, let's see, -3 and +5, probably already see what this is, but in case you had any doubts, you could always find the average, and that would be +1. So at x equals +1, somewhere along this vertical line is our vertex, because this is the center of the graph, or the line of symmetry of our graph. And I don't know where the vertex is on that line, but I know that it will lie on that line somewhere. So we do know that the vertex has an x-coordinate of +1. We do not know the y-coordinate because 2 points is not enough given information to define an absolute value graph. How about 3 points? Okay, let's try this one. We've got a -2, +4, and 0, -2, and 3, 1. And we don't know anything about the relationship between these 2 points ahead of time. So we need to make an observation here. Pretty hard to tell where the V is. It's tempting to think that that lowest point right here is the vertex. But we should not assume that. We don't know that that's really the lowest point of the graph just because it's the lowest given point. It also is not meaningful that it's on the y-axis. So we do have to make an observation about whether this opens up or down. And I'm going to say that it seems clear that it's opening upward because of the 2 higher points being apart from each other. Keep in mind that absolute value graphs are made of 2 lines that intersect at the vertex. So we're looking for 2 intersecting lines. I'm going to try finding the line between these 2 points and see if I can make an absolute value graph out of this. Okay, so if we look at those 2 points and assume that they are on a line, right away I see that I've got the y-intercept figured out here because it's crossing the y-axis, but I don't know the slope. So let's find the slope real quick. I've got 4 minus -2 over -2 minus 0. So that's 6 over -2, which is -3. Okay, so this should be going down 3 over 1, down 3 over 1. Yeah, that lines up with that. And the equation for that line is -3x. And remember, we know the y-intercept, so that's -2. Now, if this is the layout of this absolute value graph, then that needs to continue further until it intersects somehow with a line coming down this way. There is some point where they intersect, okay, and I don't know for sure where it is, but it's a symmetric graph, which means the 2 slopes are related. So if we could find this line that has a related slope to the other line and passes through the given point, then perhaps we could find where they intersect. So now that I think I know that this is y equals -3x minus 2 over here, I want to find what is the equation of the line over here. Well, remember that the slopes are always the same ratio, but one is positive and one is negative. So I can assume that this slope is +3. But I don't know what the y-intercept is, so I need to do a little solving to find that out. I'm going to use the given point and put it in point-slope form. So y minus 1 is equal to +3 times x minus 3. And let's find what this equation is. So if I add the 1 to both sides and then distribute, I get 3x minus 9 plus 1, so the equation seems to be 3x minus 8 for this one. And now that I have two equations, it's a pretty simple thing to find out where they intersect. So let's see. If I just set those two things equal to each other, right, because they're both equal to y, I can set this part equal to this part and solve for x. And I'll find the x coordinate of the point where they intersect. So I've got negative 6x equals negative 6. So that's pretty simple. X must be 1 at my vertex. Now plug the 1 back into these two equations. Let's plug it into both to make sure we get the same y coordinate. That'll verify our work so far. You should get the right answer from just plugging it into 1, but I like to be a little cautious here. So for the first equation, y equals negative 3 times 1 minus 2 would give us negative 3 minus 2, so that's negative 5 for the y coordinate. Let's try this one. Y would be equal to 3 times 1 minus 8, which is 3 minus 8, which is also negative 5, and that verifies that we're doing this correctly so far. So this seems to be our vertex. Let's try it. Over 1, down 5. Let's get rid of some of these dotted lines and see if we can clean this up a little bit. Okay, so if we've done this correctly, that should be the vertex right there. And it does look lined up pretty well. Yeah, that looks great. I'd say we have found our v-graph. Now let's write out the equation. You can write it in either the point-slope form or the more common y-isolated form. So now, do we put 3 or negative 3? Remember, 3 is the ratio of the slopes of these two lines that cross here. This opens upward, so I'm going to use positive 3 out in front. And then, using our vertex and working backwards, I'm going to put the opposite of the x-coordinate in here and the y-coordinate the way it is out here, because remember, it's been moved away from the y to this side of the equation. And there is the equation of the absolute value graph that goes with 3 given points. And that gives you a lot of information so that you can go explore absolute value graphs on your own. Good luck.